Hello guys, welcome back to the course. In this video, we are going to start the fifth project. We are going to model and optimize roads. Let's read the problem. In urban area, finding the shortest path and optimizing traffic are crucial for solving problems like traffic jams. Efficient road planning can reduce congestions by changing roads based on real-time traffic update, leading to smoother traffic flow and shorter travel times. Improving traffic management helps create a faster and more reliable transportation system for everyone. So in the fifth project, we are going to do road modeling and optimization using OpenStreetMap Network X and also Dijkstra algorithm. Okay, let's get started guys. Firstly, you will need to install Volume. So let's copy this and let's compile the code. Next, you will also need to install OpenStreetMap Network X. Let's copy this and let's compile the code. And lastly, you need to install Network X. Let's copy this and let's compile the code. As you guys can see, we have successfully installed these three Python packages. Next, we are going to import several Python libraries. Firstly, we are going to import Volume. Next, we are going to import OSMNX. And lastly, we are going to import Network X. Okay, now let's compile the code. In this project, I'm going to pick two random locations. The first location is New York University and the second location is Columbia University. So let's say right now I'm in New York University and I want to go to Columbia University. So we are going to model and optimize the road from New York University to Columbia University. We are going to find the shortest path. Okay, let's get started. Firstly, I'm going to create a new variable. I'm going to name it origin coordinates. In this case, the place of origin is New York University. So here is the geographic coordinate for New York University. Let's copy and paste the latitude and put it inside the bracket. Next, we are going to copy and paste the longitude. And remember guys, for the longitude, we need to have negative sign. Next, we are going to create a new variable. I'm going to name it destinations coordinates. In this case, our destination is Columbia University. And here is the geographic coordinate for Columbia University. Let's copy and paste the latitude and put it inside the bracket. And we are going to add the negative sign for the longitude. Let's copy and paste the longitude and put it inside this bracket. Next, we are going to download the street network data for New York City. Let's create a new variable. I'm going to name it G. You can name it whatever you want. It is totally up to you. In this case, we are going to use ox.grabFromPlace functions. Inside the parentheses, we are going to have two things. The first one is the locations and the second one is the network type. So let's specify the locations guys. Manhattan, New York, USA. Next, I'm going to set the network type to drive. Because in this case, I'm going to assume that I'm going to drive from New York City to Columbia University. Next, we are going to find the nearest network nodes to the origin and destination coordinates. Let's create a new variable. I'm going to name it origin node. You can name it whatever you want, guys. In this case, we are going to use ox.distance nearest nodes functions. Let's put g inside the parentheses. And let's specify the locations. So let's copy and paste the origin coordinates and put it inside the parentheses. Next, we are going to do the same thing to the destination coordinates. So let's create another variable. I'm going to name it destinations node. You can name it whatever you want, guys. It is totally up to you. And we are going to use the same function, so you can copy and paste this. Inside the parentheses, we are going to have G, which is the street network data for New York City. Next, we are going to specify the locations. So let's copy and paste the destination coordinates. Okay, next, we are going to calculate the shortest path. So let's create a new variable. I'm going to name it shortest path. You can name it whatever you want. It is totally up to you. And in this case, we are going to use nx.shortestPath functions. We are going to have multiple things inside the parentheses. The first one is G, which is the street network data. Next, we are also going to have the origin node. So let's copy and paste this and put it inside the parentheses. We are also going to have the destinations node. And lastly, we are going to set the weight to length. Next, we are going to extract the coordinates for the nodes in the shortest path. So let's create a new variable. I'm going to name it path coordinates. In this case, we are going to create for loop to extract geographic coordinate for each node in the shortest path. Okay, so let's create the for loop. For node in shortest path. So let's copy and paste this and put it inside the bracket. And node is the index of this for loop. Okay, so firstly we are going to extract the latitude of the node. G.nodes. And let's put node inside this bracket. And let's put y inside this bracket. Next, we are going to extract the longitude of each node. And let's put x inside this bracket. Next, we are going to create interactive map using IPyLeaflet, and the map is going to be centered around New York City. So let's import two more libraries. The first one is IPyLeaflet. And we are also going to import map, polyline, and marker from IPyLeaflet. Okay, let's recompile this code. Let's create the map, guys. I'm going to create a new variable. I'm going to name it M. You can name it whatever you want. It is totally up to you. Okay, now let's specify the locations. Let's copy and paste the origin coordinates. And it is going to be added by the destination coordinates. And we are going to divide this by 2. Let's copy and paste the origin coordinates again. And it is going to be added by the destination coordinate. And don't forget to divide this by 2. And lastly, we are going to set the zoom to 13. So in this case, I want the map to be centered around the origin and destination's coordinates. Next, we are going to add markers for the origin and destinations. So you'll be able to see where is New York University and where is Columbia University in the map. Okay, let's create a new variable. I'm going to name it origin marker. You can name it whatever you want. It is totally up to you. We are going to set the locations to the origin coordinates. So let's copy and paste this and put it inside the parentheses. We are going to set the draggable to false. For the title, it is going to be New York University. Next, we are going to do the same for the destination place. Let's create another variable. I'm going to name it destination marker. So you can copy and paste this line, guys. However, we are going to replace the origin coordinates with the destination coordinates. So this is the coordinates for Columbia University. And obviously, we are going to change the title to Columbia University. Next, we are going to add these markers to the map. m.addLayer. Let's copy and paste the origin marker and put it inside the parentheses. m.addLayer. Let's copy and paste the destination marker and put it inside the parentheses. Next, we are going to add the shortest path to the map. So let's create a new variable called pathLine. So this is going to be like a line connecting the place of origin with the destination place. So we are going to utilize the polyline. You can copy and paste this. We are going to set the locations to path chords. So let's copy and paste this and put it inside the parentheses. I'm going to set the color to blue, but if you want to use different color, it is totally up to you. I'm going to set the fill to false. And don't forget, guys, we need to add this path line to the map. m.addLayer. Let's copy and paste the path line and put it inside the parentheses. Lastly, we are going to display the map. And let's compile the code. Okay, so it might take a few seconds. Hopefully it doesn't take too long, so just wait. As you guys can see, here is the output. So this is New York University, which is our place of origin, and this is Columbia University, which is our destinations. So this route has been optimized, and obviously this is the shortest path, guys. Okay guys, I think that's it. That's all you need to know. I'll see you guys in the next video. Bye.